So this video is for Unit 7 Biomechanics in Sport and Exercise Science and is part of assignment 7.3 looking at angular motion. So the previous video looked at specifically centre of mass, and this video is going to look in more detail at C2, centre of mass, and how it's connected to stability and instability. Now, I'm sure learning to ride a bike, you may have heard of or had stabilizers. Now, obviously, you're trying to balance on this narrow wheel, which is pretty challenging when you're learning. So we give you a bit of extra width of this base here to assist you with balance. Again, cycling, if you're cycling quite slowly, you've really got to keep your centre of mass, and remember gravity acts down through that centre of mass, above the seat, above this tiny little narrow wheel to be balanced. If the centre of mass and this line of gravity moves outside that little tiny wheelbase, then we are likely to topple over sideways. If you've ever used cleats or clips in your bike and you've forgotten to unclip before you stop, this is typically what happens. Another little thought then for you, the height of athletes and their centre of mass. So gymnasts actually typically are quite short athletes. Their centre of mass is low down to the ground. Now, given what they've got to do, particularly on things like the floor work or rotational activities that they have to do, or the somersaults and spinning that they need to do, is it that that's relevant? High jumpers typically are very tall, and therefore their centre of mass is typically quite high off the ground. It would make sense, wouldn't it, that we want to have a higher centre of mass and be able to manipulate it over the bar. The higher the centre of mass at the starting point, the less distance it's got to go up to cover the bar. And again, different positions in basketball. Typically our guards are fast, dynamic, quick, agile players are relatively short compared to maybe the centre or forward players, who tend to be taller and have a higher centre of mass and of course a bigger reach, be nearer the basket. So sometimes the sport that you perform in has a typical somatotype or body shape or height that may have a relevance in terms of their centre of mass and performance. A slightly different thought then. We've got 3 techniques for doing a squat, one of which is a stable position. The other 2 are at risk of serious injury, I would say. So here's the foot. This is what we would call the base of support between your heel and your toe. That's the bit of contact on the ground that you've got to keep your centre of mass and the line of gravity between. So this position here, apart from the fact it's quite good technique, nice strong back position, horizontal thigh, their centre of mass is within that base of support. This one, however, because they are a little bit too upright, the centre of mass is just on the edge of the base of support, a little bit further that way to the left, and they will topple backwards. In contrast, this person's too leant forward. The centre of mass and the line of gravity are just about to go outside at the front of the toe, and again, if it moves a little bit forward to the right, they will tumble forward. So a lot of the actions that we execute, that we conduct, the techniques that we do, require us to manipulate where our centre of mass is in terms of keeping us stable, and it needs to be within this base of support, the points of contact on the ground. So what about this? Which might be easier to balance with and why? We've got a headstand with 3 points of contact. We've got a handstand with 2 points of contact. So I'm hoping you would figure out that this headstand is slightly easier to balance because we're effectively making a triangular base which gives us stability in each direction. So almost like a tripod that you would have a camera on. If you had a tripod with 2 legs, not 3, it would be incredibly stable, sort of left to right, but would be very vulnerable front to back. This tripod shape, this triangle shape, gives us 3 points of contact and a therefore relatively stable base of support, as opposed to the 2 points of contact here. So the number of points of contact might, and the position that they're in, might influence how stable objects are. So hopefully through my examples, you've understood some of the terminology you need for this section. We already know center of gravity or center of mass. They are effectively interchangeable on our Earth. So center of mass, center of gravity means the same thing, and the descriptions are over here on the right-hand side. The line of gravity is essentially the force of gravity acting down through the center of mass in this vertical way, and that's the line of gravity. The base of support is the area. In some cases, it's represented by a line, but remember, if there were 3 points of contact, it would be an area. So the base of support in this case is between the two places of contact, i.e. these 2 feet. Same over here, center of mass there, line of gravity going down, base of support is the 2 points of contact. And both of these examples are relatively stable because the line of gravity is wham bam in the middle of the base of support. Again, this table tennis player has a hugely stable base, nice wide stance, low centre of mass. They've bent their knees, so their centre of mass is a little bit lower. Normally it's about belly button height, but because they're slightly squat, the base of support is lower, which also gives more stability. And the line of gravity is very much within the base of support, a hugely stable position. Now, many of our sports require us to balance or to be balanced. Gymnastics, obviously, there are examples. The balance might be static balance or dynamic balance, whilst we're stood still or whilst we're moving. If you think of beam work, on some examples on the beam, they're trying to be in a stationary position, holding a certain position and keep balance, and sometimes they're travelling along the beam and having to maintain balance in that way. Surfer, obviously, is needing to keep their centre of mass and the line of gravity within their base of support, the 2 feet positions, also whilst travelling along on the board on a wave. And so they use their arms to spread out to try to assist them to keep balance. So there are lots and lots of examples of these things. Maybe less stable as an inexperienced performer, quite upright. You can see they're off balance because the line of gravity is outside of their base of support. Their feet are too close together. Whereas an experienced player has a wider stance and the line of gravity is well within that. Yoga, great example where we do all sorts of poses, or dance, of course. This could be a dancer or somebody doing yoga. We manipulate our body position, we change, we move our centre of mass, but we're always trying to keep it within the base of support. And in this example, the base of support is 1 foot width, or toes in this right-hand example here. And the amount of error you've got is very, very tiny, because the tiniest movement one direction or the other and you will become off balance. Have a little look at this. This shows a sort of an electronic plot of this gymnast's. The little red dots represent their limb sort of segment masses, centre of masses, and this white blob with a black cross represents the overall athlete's gymnast centre of mass. I mean, how amazing is it that they do incredible movements and flips and movement across the beam and travel whilst trying to keep this little white blob here within the width of the beam to remain relatively balanced and stable. I think you hopefully will have seen that at times both of those athletes became off balance or less stable. The centre of mass moved outside this sort of width of the beam, and what they had to do was change their body position, redistribute their mass to move they stuck their arm out or their leg out to try and move their centre of mass back within this width, this base of support. This is the base of support. It's such a narrow thing to protect in terms of keeping centre of mass in. Incredible. So you could, I guess, if you can line up bits where it shows where that happens, maybe you could use a screenshot of that to show there's instability, look, going off balance, and they have to get their leg out there to shift the distribution of mass over and get the centre of mass back inside that beam. Again, there it goes out and they manipulate it to get it back in. Incredibly clever. So, who is more stable out of these two athletes, the tall person or the shorter person? Well, it's the shorter person. One factor that affects stability is having a lower centre of mass. There is much less room for error if your centre of mass is lower than there is if you are taller. So the height of the centre of mass really does make a difference. So I've given you a lot of examples of how centre of mass is very much connected to being balanced or stable, or sometimes being imbalanced and less stable. We've talked about key factors like line of gravity and base of support and height of the centre of mass, and all of those contribute to something being fairly resistant to disruption or being vulnerable and toppling and being imbalanced. So here are some definitions there. This is from literature. This is the blue textbook. So to be stable, we want to be able to maintain balance, whether still or moving, and not necessarily be vulnerable to toppling and becoming imbalanced. Even things like, even though they're perhaps a bit less sport related, maybe you could argue, cars make sense. If you've got a tall lorry or a van, they are much more vulnerable to toppling over because they've got a higher centre of mass than a low car with a lower centre of mass. Even an F1 car is incredibly low and very, very stable, and a wide base of support. If you've got a narrow vehicle that's tall, it's much more vulnerable. So what are the things that affect stability then? We've got making sure that the line of gravity is within the base of support. Having a wide base of support can help. So athletes will often have a wider stance if they want to try and be more stable, but they need to make sure that that line of gravity acting through the centre of mass, is within that base of support. Having more or less points of contact. If you balance on one foot, you're very vulnerable. If you put another foot down, you're more stable. If you have a third point of contact or a fourth, you're even more stable. Mass affects your stability. Objects with a greater mass can be more stable, harder to topple, harder to move, harder to make imbalanced. But also it's not just how much mass you have, it's what you're doing with your mass, where you distribute it. So if we were walking along a tightrope or a beam in gymnastics, we may wish to spread our arms out to our sides to distribute our mass to try to give us more balance. And that distribution of mass, and you saw in the gymnastics video, the gymnast moving her leg out or her arm out to create more balance. The height of centre of mass. To be more stable, lower down is better. Higher up is more vulnerable to rotation. And actually, of course, your musculature, your inner strength, your core strength, being able to resist bending, moving, being pushed. All of those factors clearly affect how stable objects are or you are in your sporting performance. And there are lots of sports, I guess rugby being an obvious one, whereby we have to withstand people trying to make us unstable. If you're running and you get tackled, you don't want to topple over. If you're tackling, you don't want to be pushed and barged through. You want to be really stable. So athletes will manipulate all these factors to try and be as stable as possible. Have a little look at that. You can pause the video. This was an A-level question. But I think it's really important that you know it isn't all about being balanced or being stable. A lot of our life or sporting performance is about using instability, creating imbalance actually. Let's have a look at an example. So in the sort of start position, ready position, in a sprint starts, we're in a very stable position. Our centre of mass is very much within the base of support. We've got multiple points of contact. We are not vulnerable there. In the set position, what we do is we lift our centre of mass, we move it forward, and our centre of mass is probably about here, just inside the base of support. And those of you that have done this, this is quite a vulnerable position to be in. We are ready to explode, to spring out of the blocks, but we've got to remain just that little bit balanced for a couple of seconds. Once the gun goes and we start to sprint, we remove 2 points of contact, 3 points of contact. We take a foot off and both hands off. Now our centre of mass is probably about here. Now, what do you think this body is wanting to do? It wants to fall, it wants to rotate around this point of contact. This becomes an axis, and it wants to rotate that way. Gravity is pushing down through the line of gravity, through your centre of mass, always towards the ground. And at the moment, there's nothing here that's keeping us upright until we put this foot down. So running actually is making ourselves unstable, full forward, and then we plant our next foot, which gives us stability, and we move over that foot, and then we become unstable again. So each running step is a mixture between becoming imbalanced, unstable, and then stable again briefly, running over that stride, becoming unstable again. These diagrams, I guess, just show what I've described. So here's the line of gravity through the centre of mass within the base of support. Here's the push out of the blocks, and clearly centre of mass, line of gravity is ahead of this tiny base of support here, where we want to fall forward down to the ground. There's another little bit of blurb here that just talks about if you didn't do a sprint start from crouch position, which actually is really efficient, because whilst you're in this position and you then drive away using blocks, you're pushing forces more anterior posterior, so your force is going through your centre of mass more forward, more horizontally, than if you were in an upright start. So at school you may not have had blocks, you may have just stood upright and tried to run. Well, you won't generate as much backward forward force if you're stood upright than if you're able to almost be directing the force backwards and forwards horizontally. Okay, let's move on to different sorts of examples of manipulation of centre of mass. So we mentioned high jump before and how Fosbury flop was brilliant for enabling the centre of mass to go underneath the bar by this athlete being able to get in this almost crab-like position. Now, during the run-up, obviously they're quite upright, but when they take off, they lean. The leading arm that goes over the bar first. They then begin to get into this arched position, and what they're doing is applying a force on the ground, and the force back is an eccentric force, equal and opposite. Remember, ground reaction force is eccentric, which means because they're leaning, their centre of mass sort of drops, if you like, and the force comes back and goes outside of the centre of mass, which is how they're able to start that arch, that almost rotation into that position. So they are creating angular motion by an eccentric force from the ground, a reaction force from the ground, moving outside, going around the outside of their centre of mass. Remember back the Magnus force, where a force is applied outside the centre of mass and we create spin. This is basically the athlete creating almost like a rotation spin on their body, turning their body to be able to go over and change direction backwards in that arch. Here's another example. So, forward roll. You've all done this, I'm sure. Centre of mass within the base of support, stable. When we want to start rolling forward, what we do is we tilt our body forward, we almost unweight, lean forward, and what we're doing is moving our centre of mass ahead of our feet, outside the base of support. We're creating instability, and once we become a little bit unstable, we then push with our legs to create angular motion, we begin to rotate around this centre of mass. The centre of mass becomes the axis of rotation, and our body rotates around it because we're pushing around it, an eccentric force around the outside of the centre of mass. And here we've got angular motion. We roll around our centre of mass. Remember, it moves based on our body position. And then, of course, when we want to finish the forward roll and stand up with stability, we've got to be really clever. And as we come out of the roll, out of that angular motion, we change our body position from being tight and tucked to extending it. And that extension, the arms going up and our body straightening up, slows the rotation, removes the rotation actually, and eventually, hopefully, we can stop with the centre of mass above the base of support again. Sometimes if you're rotating too much, you might topple forward. So it's all about control, changing our body position, eccentric force to create angular rotation, rolling around that centre of mass, and then controlling our rotation to stop the forward roll. Same principle applies with diving. While the divers are on the top of the board, they want to be stable and balanced. Their centre of mass is over their tiny little base of support, often their tippy toes, or in this case their hands. But you can just see here, when this diver wants to start the motion of rotation, they move their centre of mass forwards. So rather than being above their hands, the centre of mass has now moved forward over the pool, and their legs are toppling. They're creating rotation around the centre of mass. Here it's shown on the diagram. Centre of mass above the feet, falling forward, moves the centre of mass ahead of the base of support, and the diver will rotate around that centre of mass to execute the dive. So there are lots of examples of that kind of thing. We manipulate our body position to create instability, to create rotation. So we get rotation by doing that. But other events, remember, other examples are about creating stability and all the ways in which we try to remain stable. So this little section really accounted for how we manipulate centre of mass. We change the position of the centre of mass to maintain balance and stability in sport, or to use it to create angular motion.